page 3 of the formative, guys. So questions 10 and 11. Number 10 is just a picture of a residual plot, and they ask you, based on this residual plot, is a linear regression model appropriate? And there is just a bunch of random dots here, so yes, a linear model is appropriate. This is exactly what we want in a residual plot, random scatter. All right, number 11 is a situation where they give you a bunch of different data. We're talking about GPAs in college and how much money they earn after college. And we're trying to see, is there a correlation between student GPAs and how much they earn after graduation. And the first question says to write an equation of the model. So we're looking for the equation y hat equals a plus bx. But based on the information they give us, we need to use this equation over here. We need to find the slope first. We can't actually use our calculator to do linear regression because we don't have all the data. When we don't have all the data and they give us summary statistics, we need to use this formula. So I'm just quickly going to write down what they gave us. They gave us that the average GPA was 2.9 with a standard deviation of 0.4. And we have the average salary at $47,200 with a standard deviation of 8,500. Oops. And the reason I have X is because we know that we're trying to predict salary based on mean. So X is going to be based on GPA. So X is going to be GPAs, Y is going to be the salary, or the predicted salaries. So that's why I labeled X as the mean and Y as the salary. So with this, now we use that equation where we can find the slope. Equals R. Hey, they also give us R right up top there. So 0.72 times the standard deviation of Y over the standard deviation of X. 0.4. Close my parentheses a little too early. Looks a little sloppy there, but you end up getting a slope of 15,300. All right, fantastic. We have the slope, but we still need the y-intercept. We still need a, and that's where we have to use this other equation. I'll put it in pink. If you remember, it's y bar equals a plus bx bar. In other words, if you have the y average and the x average, you can plug that point in and solve an equation. So we have y bar, we have x bar, and we have the slope. We can plug those three things in and solve for the y-intercept. So plugging those three things in, it's 47,200 as y bar equals a, we don't know what the y-intercept is, plus 15,300 times x bar, which is 2.9. Okay, a little bit of multiplication, a little bit of subtraction. You would solve this and you would have a equals 2,830. Now we have our slope and we have our y-intercept. I wish I would have given you guys more space to do this problem. I apologize. So yeah, our final equation would be y hat equals 2,830 plus 15,300x. Or we can say that the predicted salary is this times the GPA. Same equation, just substituted in the context for the variables. All right, so that's getting the regression equation by hand. Letter B says, do you think these predictions will be reliable? Well, to see how reliable this model is, we would need to look at, how strong is the model? And they give us an R value of 0.72. And the other thing that we would really need to look at is the residual plot, which we don't have here. So all we really have to work with is this R value 0.72. And for something like this, I would say maybe somewhat, you know, since the correlation seems to be moderately strong. At R equals 0.72. All right, and then letter C says your brother just graduated from college with a GPA of 3.3. So we know our bro has a GPA 3.3. He tells you that based on this model, he has a residual of negative 1880. So what salary is he earning? A lot of information given there, but what's going to help you guys is the residual formula. You guys know that for residual, this is just actual minus predicted, or sometimes they say observed minus predicted, so what actually happened. Well, what we do know is we know the residual, right? They told us that the residual was negative 1880. We don't know what his actual salary is, right? That's what we're trying to figure out. But could we figure out what his predicted salary is? And yes, I could figure out what his predicted salary is because I have his GPA. So I know his GPA is 3.3, and I can use my equation and plug in 3.3. And get that his predicted salary. Actually, I'm just going to take all this and plug it in for predicted, since that would give me his predicted amount. I'm going to say minus close that parentheses. Again, we get the predicted amount by plugging in his GPA into our regression equation, and this would give us his predicted salary. So his actual salary, we don't know, minus his predicted salary, and then over here we have the residual. Solving this, we get 51,440. So our brother, your brother, actually earns 51,440, and since he has a negative residual, this is actually less than what the